Beneath our feet, a hidden world exists, a world of immense power and slow, relentless movement. This is the realm of tectonic plates, the colossal fragments of Earth's lithosphere that dictate the very face of our planet. These plates, like pieces of a giant jigsaw puzzle, are in constant motion, though we rarely notice their subtle shifts. But their impact is undeniable, shaping continents, carving oceans, and unleashing forces that can shatter landscapes in an instant. The Earth's crust might seem solid and unchanging, but it's a deceptive illusion. In reality, it's fractured into these massive plates, each one a distinct piece of Earth's outer shell. These plates are not static, they drift atop the semi-molten asthenosphere, a layer of the Earth's mantle that behaves like a viscous fluid over geological timescales. The forces that drive these plates are colossal, originating deep within the Earth's fiery core. The movement of tectonic plates is a slow and majestic dance, a ballet performed over millions of years. These colossal slabs of Earth's crust are in constant motion, though we rarely notice it. Driven by convection currents in the mantle, these plates drift and grind against each other with unimaginable force. The energy involved in this process is immense, enough to create mountains, trigger earthquakes, and form ocean basins. The heat from the Earth's core creates these currents, causing the asthenosphere to churn and flow. This layer, just below the crust, is semi-fluid and allows the solid plates above to move. This movement exerts pressure on the tectonic plates, pushing and pulling them across the Earth's surface. At the boundaries where these plates meet, the interactions can be both constructive and destructive. Imagine a pot of boiling water. The heat from below causes the water to rise, cool, and sink again, creating a circular motion. This is a simple analogy for the complex processes happening deep within our planet. The Earth's mantle behaves similarly, albeit on a vastly larger and slower scale. The mantle's convection currents are like the boiling water's circular motion, but they move at a pace that is almost imperceptible to us. These convection currents are the engine driving the movement of tectonic plates, shaping the very foundations of our planet. They are responsible for the creation of new crust at mid-ocean ridges and the destruction of old crust at subduction zones. The speed of this movement is almost imperceptible to us, averaging just a few centimeters per year. Yet this slow pace is relentless and unyielding. This may seem insignificant, but over millions of years, these tiny movements add up, rearranging continents and sculpting the Earth's surface. The positions of the continents we see today are the result of this ongoing process. It's a slow-motion ballet with dramatic consequences, a dance that has shaped the world we know. From the highest mountain ranges to the deepest ocean trenches, the evidence of this dance is all around us. The story of our planet is written in the rocks, a testament to the power and persistence of tectonic forces. The boundaries between tectonic plates are areas of intense geological activity. These regions are where the Earth's lithosphere, the rigid outer layer, is constantly being reshaped and reformed. The interactions at these boundaries are responsible for some of the most dramatic and powerful natural events on our planet. Here, the immense forces generated by the Earth's interior manifest in dramatic and often destructive ways. Volcanic eruptions spew molten rock and ash into the atmosphere, while earthquakes can level entire cities in seconds. These forces are a reminder of the dynamic nature of our planet. There are three main types of plate boundaries: divergent, convergent, and transform. Each type of boundary is characterized by the movement of the plates relative to each other, and each has its own unique set of geological processes and features. Each type creates unique geological features and hazards. For instance, divergent boundaries can lead to the formation of new oceanic crust, while convergent boundaries can create towering mountain ranges. Transform boundaries, on the other hand, are often the sites of significant earthquake activity. At divergent boundaries, plates move apart, allowing magma from the Earth's mantle to rise and solidify, creating new crust. This process is a fundamental part of the Earth's geological cycle, constantly renewing the surface of our planet. This process is most evident in the mid-ocean ridges, vast underwater mountain ranges where new ocean floor is constantly being formed. These ridges are teeming with unique marine life, adapted to the extreme conditions found in these environments. These ridges are like giant scars across the ocean floor, marking the birthplaces of new crust. They stretch for thousands of kilometers, forming a continuous chain that encircles the globe. Convergent boundaries, as their name suggests, are where plates collide. This collision can result in one plate being forced beneath another in a process known as subduction, or in the plates crumpling and folding to form mountain ranges. The outcome of these collisions depends on the types of plates involved. When an oceanic plate collides with a continental plate, the denser oceanic plate is usually subducted beneath the lighter continental plate, leading to volcanic activity. When two continental plates collide, they crumple and fold, creating towering mountain ranges. This process can take millions of years, but the results are some of the most awe-inspiring features on Earth. The Himalayas, a testament to the immense power of plate tectonics, are a prime example of this process. These mountains continue to rise even today as the Indian plate pushes northward into the Eurasian plate, demonstrating the ongoing and dynamic nature of tectonic activity. When an oceanic plate collides with a continental plate, a dramatic and powerful interaction occurs deep beneath the Earth's surface. The denser oceanic plate is forced beneath the lighter continental plate in a process called subduction. This process is not just a simple sinking, it involves complex geological mechanisms that have been shaping our planet for millions of years. This subduction zone is a region of intense geological activity, often associated with powerful earthquakes and volcanic eruptions. These natural events are a direct result of the immense forces at play as the plates interact. The friction between the two plates generates enormous amounts of heat and pressure, creating conditions that can lead to the melting of rock. This intense heat and pressure can melt rock and create magma, a molten material that is crucial in the formation of volcanic activity. This magma, being less dense than the surrounding rock, rises to the surface, erupting as volcanoes. These eruptions can be both destructive and awe-inspiring, reshaping the landscape in dramatic ways. The Ring of Fire, a zone of intense volcanic and earthquake activity encircling the Pacific Ocean, is a stark reminder of the power of subduction zones. This region is home to about 75% of the world's active and dormant volcanoes. The Ring of Fire's subduction zones are responsible for some of the most powerful and devastating earthquakes and volcanic eruptions in recorded history. Volcanoes, though destructive, are also creators. Their eruptions spew forth fertile ash that enriches the soil, making it incredibly productive for agriculture. This fertile volcanic ash can transform barren landscapes into lush green areas, supporting diverse ecosystems and human agriculture. Additionally, volcanic eruptions can create new landforms, adding to the ever-changing face of our planet. Transform boundaries are where plates slide past each other horizontally. Unlike subduction zones, these boundaries do not create volcanoes but are still sites of significant geological activity. These boundaries are often associated with powerful earthquakes as the plates lock together, building up stress over time. When this stress is suddenly released, it results in a seismic jolt, causing the ground to shake violently. These earthquakes can be extremely destructive, impacting human settlements and natural landscapes alike. The San Andreas Fault in California is a prime example of a transformed boundary. This fault line stretches over 800 miles and is a significant source of seismic activity in the region. Often described as a ticking time bomb, the San Andreas Fault serves as a constant reminder of the Earth's restless nature. The potential for a major earthquake along this fault line is a concern for scientists and residents alike, highlighting the need for preparedness and understanding of our planet's dynamic systems. The relentless movement of tectonic plates has left an indelible mark on the Earth's surface, shaping our planet's geography over millions of years. Continents have drifted across the globe, oceans have opened and closed, and mountain ranges have risen and eroded away, all driven by the unseen forces of plate tectonics. The Earth's surface is a tapestry woven from these movements, a testament to the power of geological processes. The continents we see today were once joined together in a supercontinent called Pangaea, which began to break apart around 200 million years ago. The fragments of Pangaea drifted apart, eventually forming the continents we know today. The Himalayas, a testament to the immense power of convergent plate boundaries, continue to rise today as the Indian plate collides with the Eurasian plate. These mountains, home to the highest peaks on Earth, are a stark reminder of the ongoing forces shaping our planet. The story of tectonic plates is a never-ending saga, a tale of creation and destruction that has been unfolding for billions of years. The Earth's surface is in a constant state of flux, shaped by forces that operate on a timescale far beyond human comprehension. Understanding these forces is crucial for comprehending the planet we call home. By studying tectonic plates, we gain insights into the formation of mountains, the distribution of volcanoes and earthquakes, and the very evolution of life on Earth. These insights not only satisfy our scientific curiosity, but also help us mitigate the risks associated with natural disasters. The dance of the tectonic plates is a reminder that our planet is a dynamic and ever-changing system. It's a humbling thought, knowing that the very ground beneath our feet is in constant motion, driven by forces that have shaped Earth's history and will continue to do so for eons to come.